Hello students, welcome back to Wisdom Rise. Today's topic of the day is oxidation number. In this class, we are going to discuss what is the oxidation number and how we can calculate the oxidation number. Okay, so if we talk about the definition of oxidation number, so it is an imaginary charge. It is an imaginary charge. It is an imaginary charge gained by an element when it goes from its elemental state to combined state in molecule. Okay, so oxidation number is an imaginary charge gained by an element when it is goes from its elemental state to combined state in a molecule. Okay, so we have some like it is imaginary. It is not an actual charge. Okay, it is an imaginary charge in a of an element in their molecule. Okay, so we have some rules for the calculation of oxidation number. So firstly, we have to revise these rules, and after that, we will solve some question. Okay. So the rule number one. So the element fluorine have -1 oxidation number in all their compound. Okay. So we know that fluorine is the electronegative element. Fluorine is the highest electronegative element. Okay. So in any compound of fluorine, it has always -1 oxidation number. Okay. Next thing, next thing, oxygen, oxygen atom. Okay. So oxygen atom have multiple oxidation state in oxide. The oxidation number of oxygen in oxide is -2. Okay. In peroxide, peroxide is like oxygen oxygen bond. Okay. In peroxide is -1. In superoxide, in superoxide, superoxide is like CO2. Is in superoxide is -1/2. In superoxide is -1/2, and in ozonides, in ozonides is -1/3. Okay. If oxygen attached with fluorine, so fluorine have always -1, so oxygen have to be plus charge. Okay. So in OF2, oxygen have +2 oxidation state. Okay. So oxygen have plus oxidation state when it attached to the fluorine atom, because fluorine atom always gain -1 oxidation. This is the rule number 2. Okay. Now move forward. The rule number 3. Okay. So hydrogen atom. So hydrogen atom have two type of oxidation state in their compound. If hydrogen attached to electronegative element, then oxidation state of hydrogen is +1, and hydrogen attached to electropositive element, then its oxidation number is -1. Okay, so hydrogen have two oxidation state in their compound. If it attach with an electronegative element, it is +1, and if it attach with electropositive element, it is -1. Okay, after the hydrogen, after the hydrogen, after the hydrogen, now in rule number 4 in any compound, in any compound, the sum of oxidation state or oxidation number of all atoms is equal to 0. All atom is equals to 0. Rule number 5, in elementary state. Elementary state means the state from which a element obtained in the universe or obtained in the earth. So in elementary state or free state, the oxidation number of an element is 0. Okay, the oxidation number of an element is 0. Now, in polyatomic ion made by more than one atom, polyatomic ion or ions or general ions. In polyatomic ions or general ions, the sum of oxidation number of all the atoms is equals to their charge with sign. Okay, their charge with sign. These are the 6 important rules for the oxidation number calculation of any atom. Okay, these are the 6 important. Okay, now suppose we have to calculate the oxidation state of sulfur. Okay, in H2SO4. So we are going to calculate the oxidation number of sulfur. Now we have to understand. So hydrogen attached with electronegative element. So the oxidation state of hydrogen is +1 multiplied by 2. We have to calculate sulfur, so we assume that the oxidation state of sulfur is X. And here all the oxygen is attached to the sulfur. So there is no peroxide, and in general oxide the oxidation state of oxygen is 2 multiplied by 4 oxygen, and the sum of the oxidation state of each element in a compound is 0. So equals to 0. So it become +2 plus x minus 8, and it become x minus 3, or it become x is equals to, sorry, x minus 6 is equals to 0. So it become x is equals to +6. So the oxidation state of sulfur in H2SO4 is +6. The oxidation state of sulfur in H2SO4 is +6. Okay. Now we are going to calculate some oxidation state. So our next example is oxidation state of H2. So it is the elementary state of hydrogen. So the oxidation state is 0. Okay. Now if we consider ClO minus, okay, so it is a polyatomic ion. The oxidation number of Cl is X and oxygen in oxide is -2 is equals to, in the polyatomic ion the oxidation is equals to their charge, so it is equals to -1. So X is equals to -1 plus 2 is equals to +1. So the oxidation number of chlorine in ClO minus is +1. Now the next polyatomic ion is NO2 minus. So nitrogen, the oxidation state of nitrogen in X, oxygen is -2 multiplied by 2 is equals to -1. So X minus 4 is equals to -1. So oxidation number of nitrogen in NO2 minus is +3. Okay. Now K2CrO4. Okay. So we have one more rule, that rule number maybe 7, that alkali metals always have +1 oxidation state and alkaline metals always have +2 oxidation state. So oxidation state of potassium is +1 multiplied by 2 potassium. Chromium we have to calculate, and oxygen is -2 multiplied by 4 is equals to 0. So oxidation state become X is equals to plus 6. In K2CrO4, the oxidation state of the potassium is the oxidation state of potassium is plus 1 and the oxidation state of chromium is plus 6. Okay, now the oxidation state of sulfur in Na2S4O6. Okay, Na2S4O6. So sodium is the alkali metal, so it have always plus 1 for 4x because one sulfur have x is minus 2 multiplied by 6 is equals to 0 plus 2 plus 4x minus 12 is equals to 0. X is equals to 10 by 4 which is 2.5. So the average oxidation state of sulfur 1 sulfur is 2.5. Okay, clear? Now we have one more example CrO5. Okay, so in CrO5 bonding look like this. एक oxygen, two oxygen, and there is four oxygen by the peroxide bond. So if CrO5, so we can write it like CrO4 and O. Okay, Cr is X, O4 is minus 1 multiplied by 4 because these four oxygen have peroxide bond and oxygen in peroxide have minus 1 oxidation state. Plus minus 2 is equals to 0. So x is equals to minus 4 minus 2 is equals to 0 and x is equals to minus 6. So the oxidation state of CrO5 is minus 6. Now, the oxidation state of sulfur in H2SO5, this is also exception. The bonding look like this O, S, O, O, O and H. So these two are peroxide oxygen and these two have minus 1 oxidation state. So we can write it H2SO3 and O2. So plus 1 multiplied by 2 plus X plus minus 2 multiplied by 3 plus minus 1 multiplied by 2 is equals to 0. Plus 2 plus X minus 6 plus 2. Okay, sorry, here minus 2 equals to 0, so x is equals to plus 6. Here, these two oxygen have minus 1 oxidation state because these two oxygen have peroxide linkage. Clear? Now, I hope so you got the concept. The oxidation number of NH3 is so the nitrogen have X oxidation number and hydrogen plus 1 multiplied by 3 is equals to 0, so x is equals to minus 3. Okay, these are the oxidation state. Okay, now the next topic in oxidation number is paradox. Paradox is like oxidation which is look like that. Okay, fractional oxidation state, but actual value is different. Okay, so the first paradox is C3O2. Okay, if we calculate the oxidation of C3O2, we get the oxidation number of carbon is 3x plus minus 2 multiplied by 2 is equals to 0. So x is equals to minus 4 by 3. The oxidation state of carbon in C3O2 is minus 4 by 3. But in the molecular structure, it look like this way. Oxygen attached to carbon, attached to carbon, attached to carbon and attached to oxygen. These carbon have minus 2. Okay, these carbon have plus 2 oxidation state and this carbon have 0 oxidation state. So it is different from the we calculation. Okay, so this is called as paradox oxidation number. Paradox of fractional oxidation number. Same, we have one more example in paradox that is Br3O8. Okay, so if we are going to calculate, it becomes 3x plus minus 2 multiplied by 8 which is equals to x is equals to 16 by 3. Okay, but in the compound Br attached to Br attached to Br, it look like O, O and O, O and O, O and O and O. Okay, so the terminal bromine have plus 6 oxidation state, but the center bromine have plus 4 oxidation state. These are the paradox oxidation state. These are the paradox oxidation state. Now we have some important notes for the oxidation state is that P block and F block elements have P, F and D block elements have variable oxidation number. Okay, P, F, and D block elements have max variable like multiple oxidation states, multiple oxidation number. Okay, I hope so. Oxidation concept is clear. Now you have some homework for the calculation. First is you have to calculate oxidation state of Mn in K1O4. Second is you have to calculate oxidation state of chromium in Cr2O7. Third is you have to calculate the oxidation number of CCl4. Okay, so we have one other important note that a element can have multiple oxidation state. It can be positive, negative, and zero. Such as we have example C4, CCl4, CH4, CCl4, and CHCl2. Okay, here the oxidation number of uh, carbon is -4, here +4, and here 0. So a same element in different compound have different oxidation number, can have different oxidation state. Which compound elements? P, D, and F block element, not the S block element. S block elements have fixed their oxidation state. It is +1 and +2. All the alkali metals have +1 oxidation state. All the alkaline metals have +2 oxidation state. Okay, metal. Okay, I hope so. The concept was clear. Thank you for watching. If you have any concern, just comment. Okay, thank you.